Alright, Assalamualaikum and good morning. Today we will cover on heating and control device in resident aircon control system. Alright, so the content of this topic are as listed: introduction, residential aircon equipment, basic residential control circuitry, package aircon control, split system, AC, heat pump control system, heat pump, sequence of operation, advanced residential control system, field wiring, check, test and start procedures. Alright, the purpose of heating and control device is to supervise the operation of electrical loads on equipment in order to maintain desired temperature that set by equipment. Okay. Basically, you will cover the control will cover compressor, heating source, condenser fan, blower motor. Control system must maintain safe operation to ensure the equipment is not. So, how to ensure the equipment is not damaged? We will see later on what are the control system or control equipment that this heating equipment use. Okay, basically when you said residential AC equipment belong to two equipment which are package AC unit and split AC system. Okay, for package AC unit, basically it's the house of all component except thermostat. Okay, and because thermostat is inside the room. Then there's two types: air-cooled package and water-cooled package. Location of installation is depend on configuration of the units. Say the other one. This is an example of package unit. Okay, split AC system. Okay, for split AC system, basically it has condensing units, which are compressor, condenser fan motors, and controllers. The function of it is to remove heat. How that it remove heat? By using air source. And also you have a evaporator and blower mounted in FCU, fan unit. Okay, this is a drawing of split units where we have a condensing unit and outside, and for the power we have a fuse, this connector, we have a liquid line, we have a suction line, we have a condenser drain, okay. And this is a furnace, return air duct and cooling coil in insulated enclosure. So that's it for split system. Okay, what are the control circuitry that has in basic residential? Basically, we have a compressor control circuit, condenser fan motor control circuit, evaporator fan motor control circuit, safety control circuit, furnace control, and heat pump control. Compressor control circuit, this is the first one. First basic control circuit, device that stop and start the compressor. This is not inverter lah. Okay? Start and stop. On a low voltage control system, the thermostat open and close to energize and de-energize the contactor, which start and stop the compressor. So actually being controlled by thermostats, wherein energize and de-energize the contactor, compressor contactor, then it will run the compressor. And the other one, condenser fan motor. This one is connected to the contactor to ensure that it is operating whenever the compressor is in operation. So it have only one contactor. This contactor will, if it energized, so the compressor will be running. At the same time, the condenser fan motor also running. Okay, this is a schematic diagram for contactor circuits controlling compressor, showing connections of condenser fan motors. So as in the slide before say that it has only one contactor. So this is the relay. This is the contactor. So what happens? This is the thermostat. Yeah. When this thermostat when the temperature is increased, this thermostat will increase and connect these circuits. So in this case, you have the fan is moving. So maybe you have another circuit to the fans. Okay. So this is the switches. So for the system to function, the switch must be on. The switch on, and this is closed. When the temperature is high, so what happens? There will be a current moving through these circuits. So when it moves through these circuits, this contactor relay will energize. When this is energized, what happens? This is the contactor that is normally closed will become the normally open contactor will become closed. Okay. So when this is energized, so this one will be closed and this one will be closed, and then the compressor and condenser fan motor will run at the same time. Alright, condenser fan motor, some of them are controlled by outdoor thermostat set at temperature that will maintain the constant discharge pressure. So let's see the diagram. For example, here it has a CFPF, condenser fan motor pressure switch. So what is its functions? The function is to maintain the same pressure, so that when the pressure is achieved, then this condenser fan motor will turns or operates. If the pressure is not achieved, then this condenser fan motor will not operate. This is to have a good efficiency. So next is evaporator fan motor control circuit, which is controlled by indoor fan relay, which is controlled by the thermostats. Okay. So let's see the diagram. Okay, here is the diagram of the complete one. Okay. Basically, the fan is controlled by this one, indoor fan relay. So when this is indoor fan relay is energized, so what happened? The contactor of IFR, okay, this one will energize. Okay, this one, okay, this will be from normally open to closed position. How does this one function? This one is function if this thermostat is increase in temperature. So this one will be closed. This line will have an electricity and then go towards and it has indoor fan relay that will be closed, that will be energized and close the indoor fan relay contactor. When this is closed, then you have indoor fan motor. Indoor fan motor will turn the fan. Right, another circuit is SMPTE control circuit, which is connected in series with the contactor coil. One of few exceptions is internal thermostats in the compressor, which break the power wire inside the compressor. So basically, the compressor also have a internal thermostats, having a circuit outside the compressor. A series connection ensure that in case of unsafe condition, compressor will be energized. So let's see the circuit. For example, this is, we go back to previous circuit, but this time it has high pressure and low pressure switch or sensors. Okay. So when it is too high pressure, so what happened, this one will be open. It's open, so you will the system will not have this relay, contactor relay will not have electricity and will be de-energized. So what happened when this is de-energized, this one will be changed, okay, because this relay control the contactor, this contactor, right? So same as before. So what happens when this is low pressure, then this one will be sensor will be low and there will be no electricity going to this relay contactor, and it is put in series to ensure that either one is failure, it will ensure that the compressor will not running. Okay, before we jump to furnace control, other than having a high pressure switch and low pressure switch that is in series with the relay contactor, in the compressor also it has overloads, internal overloads, okay, inside the compressor. So when the load is too big, so this overload will be break off and this compressor will not have any electricity. Okay, furnace control. What its function for is to supervise the operation of the loads in the gas furnace, maintain a reasonable temperature in the condensate space. This is for heating, heating season. So heating in winter season. So basically is to protect the structure equipment from excessive temperature and flames due to equipment malfunctions. Next we have a heat pump control. Heat pump in the cooling mode and air conditioning in cooling mode operates lights, and the control system are very similar. So as you know, air conditioning is in Malaysia we have aircon, so it's for cooling, but heat pump is being installed in Four Seasons country, where it could heat the house or it could cool the house. Okay, so heat pump is actually reverse refrigeration by supplying heat to the structure with some additional time of supplementary heat for low outdoor temperature condition. So basically, when heat pump is function, it is reverse, because currently, as you know, the evap is inside the room, correct? And the condenser is outside the room. So if you want to heat the room, the condenser should be inside the room, the evap should be outside the room. Okay, when the evap is outside the room, cold evap and very cool weather outside the room will make whatever inside the evap system become freeze. So for heat pump to operate in good condition, it has to has a supplementary equipment that could defrost whatever heat, whatever ice that being made inside the outdoor system. Okay, that's one for heating. Okay, we already covered this basic residential control circuitry, which cover up to heat pump control. Now let's see the other one. The other one are package AC control system. All in one package. Package AC control, package AC unit control systems, gas heat electric AC package unit control system, package heat pump control system. So basically, there are three major loads that must be controlled which are compressor, condenser fan, and evaporator fan motor.